Okay, here's the deal. In this chapter, we have talked about exponential functions, we've talked about inverses, and now we're talking about logarithms. And the logarithm graph is the inverse of the exponential graph. So here on the left, we have the exponential growth graph. That's y equals a raised to the x. Reflect that over the line y equals x, and we have the graph of the logarithm. Y equals log base a of x. With an exponential graph, we had a horizontal asymptote at y equals 0. With logarithmic graphs, that's going to be reflected. The x and y are going to be switched. So we're going to have a vertical asymptote at x equals 0. So the asymptote is going to be x equals 0, a vertical line. And notice that this graph doesn't cross that asymptote, so our x values are all going to be larger than whatever the asymptote line is. So if we were to shift this graph, I don't know where I should draw this. If we were to shift this graph right 4, it would shift the asymptote over to x equals 4, and it would shift that domain to x is greater than 4. So whatever the asymptote is, your domain is going to be x is greater than that. This time, the range is all real numbers. So with exponential graphs, up here, our domain was all real numbers, and our range was y is greater than the asymptote. Because an inverse switches the x and the y, the domain of a log function is x is greater than the asymptote, and the range is all real numbers. Okay, we're actually going to look at, we're not going to actually look at all these graphs. I am going to just sketch each of these really, really quickly. Basically, just trust me. Is that weird? Just trust me. So we're looking at log base 10 of x. That graph looks something like this. Don't get super picky about accuracy of this graph, but it has a vertical asymptote at x equals 0. That's kind of what the graph looks like. This next graph is going to look like this. It has a graph or an asymptote at x equals -3. This plus 3 moves the graph left 3. So adding something to the x inside the log shifts the graph left or right, and it's opposite, just like it was with exponential graphs. So this -3 is going to move the graph right 3. So it's going to put our asymptote at +3, and then the graph would look something like that. If we wanted to talk about domain and range, we've got the asymptote, so the domain and the range. The domain would be x is greater than 0, range, all real numbers. This one, x is greater than -3, the range, all real numbers. This one, x is greater than +3, the range is all real numbers. So we looked at left and right. You might be guessing. Now we're going to look at up and down. And here's the thing. If you take this graph and shift it up or down, it's really going to look pretty similar. It's just how far over the x-axis does this go up and to the right. So looking at these, they don't look like much. But the +3 is going to move the graph up 3. And the -3 is going to move the graph down 3. So that's the important thing, is that this +3 is moving the graph up 3. This -3 is moving the graph down 3. Now, how would that change the asymptote, domain, and range? In all of these, the asymptote is 0. If you move a graph up or down, it's not going to change the asymptote, which means it hasn't changed the domain, and the range of all log functions are all real numbers. Sorry about that phone. That was my husband trying to call me. I apologize. Next up, we are going to look at what negatives do. And honestly, this is exactly the same as what negatives did when we had exponential graphs. So again, this graph looks like this. Woo! And when we put a negative in front of the function, this negative in front is going to flip the graph over the x-axis, just like it did when we had exponential graphs. So instead of starting down and at the y-axis, it's going to start up. It's going to look like that. And if we put the negative inside, a negative inside is going to flip the graph over the y-axis. It'll be a horizontal flip over the y-axis, so that graph would look like that. Now, how does this affect the asymptote, the domain, and the range? Okay, nice thing is the range for all of these is going to be all real numbers. The asymptote for all of these is going to be x equals 0. We didn't move this side to side, so the asymptote didn't change. The domain, however, x is greater than 0. We know that one. This one, is also x is greater than 0. But when we flip this over the y-axis, it is going to flip that, and we have x is less than 0. So in example 5, I would like you to summarize everything that we just talked about and see if you can figure out the transformation for each of these graphs. So the left part is like the original graph, and then the g of x is the new graph. So pause the video and see if you can figure all of those out. Okay, so in the first one, that moves up 8. This one moves right 6. Left 1 and the negative in the front flips it over the x-axis. This last one is a little bit tricky. So the negative inside is definitely going to flip it over the y-axis. But this minus 4, we could also write this log base 5 of negative x minus 4. So really, that's just moving it down 4. They just, instead of putting it after the log, they put it in front of the log for some crazy unknown reason. Don't believe we are going to go into that right now. Oh, that's 11.4. You're right. 11.4. We're done. Yay, we're done with 11.3. All right, so next up is finishing your 11.3 assignments.